All right. Hi, everybody. Today we'll be going over ITS. We've been getting a number of questions about that, so this is sure to be a pretty useful topic to dive into. As always, we have Ben here to go over it, and I'll go ahead and hand it over to you, Ben, so we can dive in.
Hey guys, good to be here. Welcome back for, I believe, our third week now. Thanks for having me, Austin. Yeah, lots to get through today. Jump right into it. Can you guys see my slides? Just someone give me a thumbs up in the
Yeah,
comments. Oh, we can see it? Okay, beautiful.
yeah,
Let's get going.
we can see it there.
All right, so I want to start with a brief recap of the past 2 weeks. You remember in our first week, we got into like what is Axelar, what makes it a unique interop solution. The main takeaway from that was that Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. The takeaways being that it's Axelar is itself a Cosmos chain. It's an L1 with 75 validators who come to consensus about each cross-chain message that was sent. It is a hub and spoke model, so every chain that connects to another chain is done via a message through the Axelar network itself, through this layer 1 of 75 validators. And that was really the takeaway of week 1, and that we're agnostic of different virtual machines, connect EVMs, not EVMs, Cosmos chains. And week 2, we asked that question of like, okay, we got this scalable decentralized interop protocol. What do we do with it? We then got into GMP. I apologize for the slides being a bit disorganized here. I'm not sure if you can see the Axelar network blocking validators in the text here. It's in this StreamYard Google slide sharing. It's different than when I have it on my own Google Slides. So I apologize for that. But what we got into in week 2 was GMP. Like, what can we actually do with the Axelar network? We covered like sending hello world messages via interacting with like the gateway contract and the gas service. We went over two-way calls, like callback functions, like a ping pong style message. We sent function signatures to mint NFTs on different chains. And today I want to get into probably the most relevant thing to a lot of people, which is actually sending cross-chain assets between different chains. And that is where Interchain Token Service comes in. Interchain Token Service, or ITS, is really just a set of contracts that is built on top of what we talked about last week. It's literally just leveraging GMP, like what we talked about last week, to be able to send assets between different chains. So you guys can remember the example of like minting an NFT on the destination chain. In this case, we're going to mint an ERC20. So what is ITS? I'll read this quickly. It allows for cross-chain tokens to permissionlessly be created or integrated by anyone. So what does that mean? There's two takeaways here, or three, let's say. Permissionlessly means anyone can do it. Created or integrated means that we can create fresh ERC20s that are deployed by ITS itself, or you can integrate custom tokens if you have some more like more customized functionality that you want for your token. And we'll get into all these scenarios in a bit. So I want to start with this whole idea of interchain token service versus gateway tokens. Some of you may have seen in our docs, or which you may have come across, this function called call contract with token. If you recall, call contract we used for sending like just a vanilla GMP string or just any GMP message. Call contract with token will do that and also send an ERC20 asset. So AXL USDC, if that rings any bells, that is an example of a gateway asset. So what is a gateway asset? These are kind of legacy assets that existed in the Axelar ecosystem before Interchain Token Service was around. That's why these exist and are still used today. These are assets that the Axelar or the Interop Labs team has actually integrated themselves at the consensus layer. Um, and they're used for like more popular assets that like just more essential to get bridged at the time. So like USDC, wrapped ETH, wrapped Bitcoin. There's about a few dozen of these assets. You can find them on our docs. Those are the main three that come to mind. AXL, USDC, of course, being probably the most widely used. But when interchain token service came into the mix, the idea came in was that like, hey, it shouldn't just be the Interop Labs team who like is able to integrate new assets and to make them multi-chain. Rather, anyone should be able to do it. It should be permissionless. So that's where ITS comes in. Over the long term, we're hoping that all gateway tokens will be ITS assets as well. Right now, they're different. But I just wanted to clarify that point in case anyone gets confused by like where does like AXL USDC fall into the mix. So sending these gateway assets is actually different than sending ITS assets. They're both quite straightforward, but today we're just going to focus on ITS because that is like the kind of present day focus and of course the future focus of Axelar. So another comparison. Some of you may have heard the term interchain token. Of course, very relevant towards the interchain token service. So interchain token service is a contract that exists on every single chain or EVM chain, let's say for now, that Axelar connects. That is just one contract we're all going to be interacting with. And remember what I said at the initial sentence here. We can create tokens via ITS, or we can integrate custom tokens. There's this important distinction here. Interchain tokens are tokens, when I say them, I mean the tokens that are like permissionlessly created by the Axelar interchain token service contract. So let me share my screen quickly just to show you what I mean. Entire screen. Cool. Can you guys see my screen? Someone give me a yes. Yep.
You should be able to see it now, I believe.
Beautiful.
Yeah.
I'm gonna be flipping between the slides and my share screen a bit.
No worries.
So interchain tokens are this is an example of our contract. It's basically a contract which the Interop Labs team has made. It's inherits from the ERC20 standard. It's quite simple. It has all your standard ERC20 functionality, but it also has, let me scroll down a bit, an interchain transfer. Oh, oops, sorry, that was the wrong contract. It inherits from ERC20. I'll talk about the interchain token standard in a bit. Has all your standard ERC20 functions, but it also should have the interchain transfer function. Oh yeah, it has it inherited from interchain token standard. So all your standard ERC20 functions, plus this interchain transfer from and interchain transfer function. And this is meant to be a simple ERC20, which you can use if you don't want to worry about having your own custom functionality. This will basically be the token that ITS deploys for you. And it's all the standard ERC20 functions plus interchain transfer built into it. On the other hand, we have, let me switch back to my slides here. We have our custom tokens. This is more robust functionality if we have like a stable coin with all this custom functionality that we want in it, or any in-game asset, for example, that we want to take cross-chain. ITS is meant to be a very flexible tool that can handle all different types of scenarios, whether it's like a custom advanced token or like a more simple, straightforward token that doesn't require as much functionality that you can just go and deploy via ITS yourself. For anyone who's used our portal, I'll showcase that as well. But those interchain tokens, that contract code I just showed you before, is technically the contract that will be deployed by our portal. So I hope this slide is big enough if you guys can see it, and there's a lot going on here, but I'll try to simplify it as much as I can. This is meant to be a kind of roadmap of all the different options that ITS provides for you. Remember, it's meant to be flexible, be suitable for any different scenario you have. So if we start at the beginning here, let's say you want to integrate your token with Axelar. First question is, hey, do I even have a token, or do I just want to completely start from scratch via like the portal? You can use ITS to create that token. You can either, if you don't have anything at all, you can go to the portal and just deploy like 10 of those interchain tokens I just shared on like 10 different chains. If you have a token already on a single chain and you just want to have like wrapped versions of that asset across different chains, you can use the portal as well to register your token on a single chain and then deploy like 9 other interchain tokens on other chains, to be bridgeable between each other and your custom token. On the flip side, if you have an existing token on like multiple chains already and you want to integrate each of those tokens on 4 chains, you can do that by hand programmatically, which we'll do ourselves. Um, the main takeaway from here is, again, to drill home that point that whether you have a token, don't have a token, you just want one canonical token being registered, or you have 4 different custom tokens, all that you want to be integrated with custom functionality, ITS will have a route that should be suitable for your needs. So there's 3 different components. There's more, but for the sake of this demo, there's 3 key components which we should map out in our head when dealing with ITS. There's, of course, the interchain token service contract itself, which we've talked about. That's like a massive contract which exists on every different chain that we have ITS connected to. I'll showcase that in a minute. And that's kind of the first contract that we're all going to be interacting with. Then there is your ERC20 contract, whether it's a token, a custom token that you're integrating yourself, or a fresh interchain token that's being deployed by ITS. That's obviously the second critical component here, is the token itself. Third, there is the manager. The manager is a contract which you use to kind of facilitate the relationship between your ERC20 token and ITS itself. So whereas ITS is just a single instance on a given chain, like on Binance, let's say we're all talking to the same ITS contract, whereas the manager is unique for my tokens integration, for your tokens integration. All of our token integrations will have unique managers. You can kind of visualize it like this. Think of it like as your buddy on each blockchain. So each chain that your token is on will have a different manager. Like if my token is on Binance, Avalanche, and Ethereum, it's connected between those 3 chains. Binance, Avalanche, and Ethereum will all have token manager contracts to go alongside my token, which is also deployed on those 3 chains. The key thing to understand with managers is that there are different types of managers, and that is chosen based on how you want your token to be integrated with ITS. There's 5 to be exact, but there are 2 critical ones which the vast majority of the cases apply to. So the first one is mint and burn, which, as the name suggests, will burn your token on the source chain when it's being moved out, and mint on the destination chain as it's being moved in, and vice versa when you're moving it back into your original chain. And remember, ITS is just using GMP under the hood. So I have an ERC20, I can call the interchain transfer function. My manager will then burn that token. That burn message, that burn will be complete on Ethereum here. We then send a message to the Axelar network. Remember from last week, the 75 validators come to consensus about a message that was sent. That message is, hey, mint X amount of tokens on the destination chain, on Avalanche. They come to consensus. They tell the manager, hey, Ben wants to mint 75 tokens on Avalanche. He's already burnt 75 tokens on Ethereum. The manager will then be the message sender of that mint function on Avalanche. So that's mint and burn. Another type of token manager is lock and unlock. You can imagine, unlike the mint and burn, which burns the token on the source chain, the lock and unlock simply locks the token on the source chain. And then when you bridge back, it unlocks it. So there's no actual minting and burning that's happening. The key thing to understand here is that you want to have a lock unlock manager in a scenario where you have like one home chain for your token and the rest of your tokens are like derived back to the value of tokens that are locked on the home chain. What does that mean? It means that you can only have one lock unlock manager. If your lock unlock manager is on Ethereum, then on Avalanche, on Binance, on all your other chains, you're going to have mint burn managers. And only on Ethereum, your home chain is where your lock unlock manager will be. You never have multiple of these. Why? Because managing liquidity becomes a nightmare. We want to avoid scenarios where someone's trying to now, some whale mints like 1 million units of your token and like, oh, sorry, your manager actually only has 500,000 unlocked, and you get into a bit of a mess there. So for simplicity's sake, we only have one unlock manager. Of course, it's a permissionless contract. You can do what you want, but it's highly advised not to do that. So this is helpful in a scenario where you have, like, imagine a stable coin, kind of like AXL USDC, right? Though it's a gateway token, but you have a scenario where you have like 1 million of your natively issued stable coins locked in Ethereum, and all your other chains have like wrapped versions of that token that is locked on Ethereum. Why do they get their value? Because it's backed by a token that's locked on Ethereum, but they themselves just kind of derive back to that. So that's our second major type of token manager, lock, unlock, and mint burn. And let's recap where we are. Interchain Token Service can deploy fresh new ERC20s or integrate existing ERC20s permissionlessly. Anyone can do that. Tokens use unique token managers to facilitate integrations. Remember, each chain your token is on has a manager that exists to handle that integration. And managers, lastly, can take on different types, whether mint burn or lock unlock. So what does the manager actually do? Well, in the case of lock unlock, it obviously holds your token while it's locked. That's where the token will live. But there's other functionality that the manager has. The most important one, in my opinion, for external developers like yourselves to be aware of is flow limits. It's kind of what we call rate limits. And that basically is a limit which you can set if you have, let's say you only want, for Binance, let's say 1,000 tokens to be ever moved in and out for a given window. Then you can set that via a flow limit. And that can be done on a per chain basis. Like, just because you set a flow limit on Binance doesn't mean Ethereum will have that same flow limit. That's really helpful in the case of like an emergency. Let's say a chain gets compromised or your contract on a chain gets compromised. You can like basically pause all bridging in and out of the chain via this flow limit. So very critical functionality that is built into your token manager rather than ITS itself. That brings us to a new tool that was released a number of months ago now, called Interchain Token Service Hub. I'm not going to speak too deeply on this because it's not super relevant to all of us here, but it's, I think, worth calling out. ITS Hub was built out when we enabled CosmWasm on the Axelar chain. Remember, Axelar is a layer 1. You can write contracts on there. All of our amplifier integrations are done on Axelar by deploying contracts for each new chain that we're integrating. So another example of a contract that was deployed on Axelar was Interchain Token Service Hub, and it's kind of like the next iteration of ITS. Why did we do this? Because before ITS Hub, like, ITS was just limited to only EVM chains, but the way it was built was via pairwise connections. You had ITS on Ethereum, on Arbitrum, on Binance, on Optimism. They didn't really know about. I mean, they were able to talk to each other, but they weren't unified in terms of the state that is being held between different chains. So things like tracking balance across all your tokens connections, tracking flow limits, what we just talked about, is all much easier to do with ITS Hub. So it brings a lot of security benefits. In the case of like a chain being compromised, you can mitigate those damages much easier via ITS Hub. Having said that, the most important thing for you all to understand with it is that ITS Hub is what is being used to kind of aggregate ITS between different chains. And what does that mean? It means that we can now have non-EVM chains using ITS as well. So like Sui, Stellar, these are all going through ITS Hub because, of course, on those non-EVM chains, the ITS Edge contract is completely different than the Solidity ones on EVM chains. So ITS Hub is what's used to kind of aggregate all these different implementations of these ITS Edge contracts. Don't worry about it too much. You're still going to be interacting with ITS, your Edge contract on Ethereum or whatever chain, the same way you would before. It's just maybe know in the back of your head that those messages you're sending are going via ITS Hub. We do have a front end available for you all to play around with if you haven't already. This QR code and that link will take you to the testnet version of the front end, so feel free to mess around there. Deploy new interchain tokens, register custom tokens to actually experience ITS. It's a really neat tool to be able to, even for non-developers, to get familiar with Axelar's cross-chain asset features without having to worry about code. Having said that, since I believe we are mostly developers here, I'm going to, let me get back to my screen share, actually step through an example of integrating a custom token. There we go. Okay, sweet. So remember what I was showing before on our demo, that there was the ability to integrate custom tokens, and then there was the ability to register new token, or to deploy new tokens, interchain tokens, that is. So like these kind of this kind of simple ERC20 with the built-in interchain transfer function. So when we actually deploy a token here, if you haven't, let's call it my test token, MTT, select the decimals. I can make it mintable if I choose to. The salt, don't worry about for now, and my starting supply. Okay, let me untoggle this. And I can use the portal to register this token on however many chains I want. I'm not going to do it for now, just to save you all the time. But what this will do, if I were to deploy, would deploy this token here across these 4 different chains, not my custom token. If I do have a custom token, I can do that right here, where I will just paste in the address of my ERC20. I don't have any off the top of my head, so I won't do it for now. But if I were to do that, it would pop up that window again, and it would register my custom token on Avalanche, because that's where my wallet is pointed to now. And then I can deploy wrapped versions, so interchain tokens, on however many other chains that I want. What does that mean? It means that the manager on Avalanche, which will be my home chain, will be lock unlock, but all the other chains that I deploy on will be mint burn, and Avalanche will be my canonical chain in that example. But what if we have like a stable coin on 3 different chains and we want it to be mint burn across all chains, right? We wouldn't use this, because this will just deploy the interchain token, right? And we wouldn't use this because I can sure register my 0x stable coin on Avalanche, but on all the other chains that I would deploy, and it would just be the interchain token, right? But we have our stable coin. We want the stable coin to be on all 3 different chains. At that point, we need to now actually integrate programmatically. So I'm going to try do it in the least programmatic way possible, just because, in my opinion, it's easier. I'm going to try basically do this via the block explorers, because all we're doing is really just calling functions on ITS, which is already deployed. I just think it's easier for you guys to replicate what I'm doing if I'm not doing it on VS Code with a bunch of like scripts running in the background. So it'll be a bit slower, but I think easier to replicate. So I'm going to start, and I'll check back for questions periodically. Actually, yeah, okay, sweet. Now I can see questions live. Okay, so I'm going to start with this token that I made. It's a very, very simple token, not much going on, but it's different than the interchain token. The point that I'm making is that it's a custom token. In this case, it's very simple. Let me delete this. This is from me testing this before. It's very, very simple, just minting and burning functionality on there, but it's custom nonetheless. So I'm going to deploy this token onto Binance. I will save that address right here. So let's say Binance is this address, and now I'm going to deploy it on Avalanche as well. So let me switch my wallet to Avalanche testnet. There's going to be a lot of steps here, so hopefully I'm able to do this without making a mistake live here. If I get too caught in a web of mistakes, I'll show you the example I did just before this talk of it not working, but hopefully this all works. Sweet. So now we have, let me just make it a bit bigger in case you guys can't see. We have a token that lives on Avalanche and on Binance, just a standard ERC20. Our goal now is to connect these 2 custom tokens so that we can actually send a unit of this token on Avalanche, from Avalanche to Binance via ITS. So the first thing, there's essentially 4 steps in integrating a token. These are all on our slides, but let me write it down here. I probably should have, oh, sorry, it's all in our docs. I probably should have had it on our slides as well, but I will write these steps down here. The first thing we're going to want to do is called the register token metadata function. This will essentially register your token on ITS from each chain, or your token's metadata, I should say. So like your decimals, your name, so that ITS is familiar with it. The next thing we're going to want to do is called register custom token. So this will be done on all chains, or on both chains here, because we're just connecting 2. This will be done on a single chain, register custom token. And then the last step will be link token, where we actually now, done on single chain. We're actually going to connect these 2 tokens that we have previously registered in our first step. Why is this register functionality necessary? And why is register custom token done only on one chain? I'll speak to it more as we're doing it, rather than to go through too much information. Let's just start going through this. Otherwise, we'll be here forever. And I'll kind of explain these more in depth as we're doing it. But these are the 3 major steps for registering these tokens and then connecting them between the 2 chains. And the last thing we'll do before we wrap is actually bridge or send the token from one chain to the other. So let's start. 0xb5 is our address on Avalanche of ITS itself. Okay, this address is in our doc. So the first thing we're going to do is what we just talked about, which is register token metadata. Cool. So this requires 3 parameters. The first is just a payable like message value. I'm going to set a 0.01. Then it needs the address of our token, which is Avalanche right here. Then a gas value. That is why I saved this way here, so I don't have to retype it every time. And when I trigger write, it's going to trigger a transaction, and you'll notice, I'll show you momentarily if this works. This is actually a cross-chain transaction. I can see this here. Sorry, this is from before. Give it a minute here. Sending a very low amount of gas, so I might have to increment the gas manually here on Accelerscan. Why is this a cross-chain transaction, and where's it going? Because all we're doing is registering. You'll note in the path here, it's not actually going to Binance, it's going to Axelar. Why? Because we're just going to, let me make it a bit bigger. We're just going to ITS Hub. Remember, ITS Hub is this last thing we talked about, this contract that lives on the Axelar network itself. And we're basically just telling ITS Hub, hey, here is the metadata for this new SCT token that I am trying to integrate. This is just an Accelerscan bug. It should pop up momentarily. In the meantime, remember I said we have to do this on both chains. So let's now do this on Binance as well. So I go to 0xb5, notice the same ITS contract on Binance address-wise as it was on Avalanche. So I'm going to go to write as proxy, register token metadata. I have this from before when I was testing it. I'm going to grab the address of my token, 76, and I'm going to call write, and confirm. Cool. I like the Binance Explorer. It pops open a new tab instead of just moving me like the other one. I don't see any questions so far. If you have any questions, just ask in the chat. Cool. So this register token metadata from Avalanche has gone through. So I'll throw in this transaction hash here into the Accelerscan block explorer. We're waiting for finality now on Binance, which is pretty fast. And in a few minutes, or hopefully less than a few minutes, we'll see this having successfully executed on Binance as well. So at this point, we will have gone through step 1 of registering the token metadata on both chains. Step 2 is going to be register custom token. This is done from a single chain. Why do we have this? It's because we're going to basically have to now generate what's called a token ID. We're only going to be doing this on one chain because in the next step, when we're actually calling, sorry, this keeps popping up. When we call the link token, we're going to also be doing that from one chain. But unlike register custom token, which will not be a cross-chain transaction like token metadata registered, this will just be a single transaction on Avalanche. This, on the other hand, will be a cross-chain transaction to actually link the token. Why? Because when we're linking the token, ITS Hub will need to be notified, just like it was for registered token metadata. And we'll only need to do this link token from one kind of home chain. So that's different than the lock unlock manager stuff I was talking about before, where we're kind of locking on Ethereum as our canonical chain and unlocking. This is just for registering the token and letting ITS Hub know where this where this linking message is coming from. So let's actually do that. You'll see it's not as hard as I'm making it out to be. We're actually going to be doing this from a different contract, not ITS. We're going to be doing it from ITS Factory, which we have just kind of to modularize the function a bit. So we have register custom token right here, 0.01. It's going to require a salt. I'm just going to grab one that I have here from before. It's just a hex value. Whoops, not here. I'm going to put it here. I'll explain why we have the salt momentarily. I'm going to pass in the address of my token on Avalanche. I'm going to pass in my token manager type, which I'll explain in a minute as well, and the operator, which I'll also explain now, which will just be my address. Okay, so the salt. The salt, why do we have that? We have that because it's going to be used to generate what's called our interchain token ID. Let me actually execute this in the meantime, so we don't have to wait. It's going to be used to generate what's called our interchain token ID. The interchain token ID is going to be kind of like the global identifier for your tokens integration across all chains. It's very important. It's kind of how ITS will know which token it's bridging to from chain A to chain B. What does that mean? It means that your token ID will have to be the same on Avalanche as it is on Binance. How do you calculate that token ID? It's in the ITS contract. I won't go through it now, but it's basically hashing your deployer address, which is just the message sender, with this unique salt. So your salt will have to be different for every different token integration you do, but the same across different chains that you're connecting. So that's the point of the salt. Token address is self-explanatory. Token manager type corresponds to, remember the different token managers we were talking about before, like lock, unlock, and mint burn. It's just an enum on the contract level. And for mint burn, which is what we're doing, it's going to be type 4. You can see the full list of types, token manager type here. So mint burn corresponds to number 4. Native interchain token is for tokens deployed via the portal. Mint burn from we'll just call transfer from on your token instead of a transfer. Lock unlock fee will apply a fee for locking the token. And lock unlock we talked about before. These are the most two important, number 3 and 5 here. Native interchain, you don't ever really have to worry about it. It's just what the portal will be using under the hood. So that's why we're passing in type 4. And then the operator. I passed in my own address here. Why? Because the operator is going to be the address which can set flow limits. Remember, flow limits is like the rate limits on your manager. If you ever want to like pause all bridging or set it to like just 10 tokens a day, this will be the address who can do that. So let me confirm, view my transaction. Hopefully I did it correctly. Verifying. Agonizing wait, hopefully not reverting. Fail. Okay, what did I do wrong here? Deploy, where was it? Register custom token. Murphy's Law of live coding. Let me grab a different salt. If I do get blocked here, I'll walk you through my old example so we don't spend all day here. Avalanche, 0xC5, token manager 4, operator is me. Is this correct? register custom token. Okay, let's see. Hopefully this works. If not, I'll go through a previous example I had done. Okay, this one worked. I must have used a salt value that was previously used before. So ITS was complaining about that. Cool. So I can see here in the logs, if I go through it, a bunch of helpful stuff, but the most important thing will be that the interchain token ID was claimed. So this is my interchain token ID now, 5AE7. When I actually link it to Binance, I'll expect to see the same token ID there. And some roles are added to my token. And then the token manager, remember the buddy for our token was now deployed. So it lives right here. This is the address of my token manager, which I can see here on Snowtrace. It's just a contract. And I can also see it was connected with this same token ID of 5AE7. And I can see all the info about my token manager contract, most of which we don't really need to worry about. The only kind of relevant stuff is like the add flow in and the add flow out. So like incrementing the flow of tokens for our flow limit, see if we ever hit the kind of rate limit that we have is probably the most relevant. And adding new flow limiters, like who can actually set that rate, and good stuff like that. Great. So at this point, let's take us back to here. We've done two things. We have registered the token metadata on Binance and on Avalanche, and we have registered the custom token on Avalanche. This is not a cross-chain function, so we won't actually see that being done on Accelerscan. The next and final thing I have to do is actually make a cross-chain transaction to connect the tokens on Avalanche to Binance. So let's do that right now. I'll go back from here to our interchain token factory. I will now look for link token, which is right here, 0.01. I need to make sure I pass in the same salt as before, which, do I still have it? No, I lost it. I think I have it written down here. The salt, the destination chain, where are we linking to? We're linking to Binance. What is the address of the token on the destination chain? It is this guy right here. What is the token manager type that will be on the destination chain? It's just going to be 4 because we want to mint burn on both sides. Link params is just going to be who's the operator of the token on Binance. I want that to be me again. And then the gas value will pass in matching the message value. So 0.01. Also probably won't be enough gas, but let's make this call. Hopefully this one works smoother than before. View transaction. Nice, it went through. So I can throw this transaction hash right onto Accelerscan. See if there's any questions. Okay, not enough gas. Let me top up manually here. Notice this time the destination chain is Binance, not Axelar, because we're not just going to the Axelar ITS hub, we're actually going to Binance to link the token between those two chains. So we're waiting for the transaction to be finalized. Remember, while we have some time, brief overview of Accelerscan, we can see the time spent, the contracts we're dealing with. Since it's ITS, it's actually a labeled contract here, which is nice. I can see how much gas we paid, what the fee is for the base fee. There's also the execution fee that we're going to be paying for as well. I can see the transaction was confirmed on the Axelar network, remember, by the 75 validators. You can see the transaction on Snowtrace. And momentarily, we should see the transaction actually being approved on Binance. There is, however, before I can actually transfer the token between the two chains, there's going to be one more critical step that I need to do. That is on the token itself. On the token, we have actually, first of all, we haven't, oh no, I guess we technically did mint some in the construction here, in the constructor here. But you might be asking the question of, if we're minting and burning the token, who can actually, like, the role has to be set, right? Not just anyone can mint or burn your token. That'd be a super terrible security flaw. So we can check here, the minter role needs to be granted to who? If anyone wants to guess, it is the token manager. Remember, our kind of buddy who facilitates the relationship. So I can see the has rule. Where is has rule? Oh, there it is. Has rule of the minter. We want to check if our manager has it. Our manager's address is right here, is in the logs for one of our functions that we called for register custom token. So if I see it, it's false. That means when we actually try to transfer our token, it's going to fail. So let me actually grant that rule while we're waiting here. And I'll need to do this on both chains, on Avalanche and on Binance. Otherwise, when the token gets bridged to Binance and it tries the manager tries to mint it, the token will be like, hey, what are you talking about? And revert. Okay. Now if I call this again, this is now true on Avalanche. I'm going to swap to Binance here quickly to grant the role there as well. I know this is a very convoluted way of doing things through the Explorer and through Remix, but I hope it's easy to replicate if you guys are easier to replicate than if I do it with just a bunch of scripts. But please someone correct me if I'm wrong about that. So Binance, I'm going to do the exact same thing. I'm going to grab the minter role. I'm going to throw it into grant role here. Oh no, not grant role, admin. Grant role for the minter. And the account will be, oh, it's actually, I need the manager to only go through after we've linked. Hopefully this goes through without any errors. Let me see, what did I pass in again? Go back, link token, Binance token address was correct, I believe. No, it looks like I did something wrong here. Let's see. If this fails for time, oh no, there we go. I did do it right. Cool. So if I actually click on the executed transaction hash here, it takes me to the native Binance Explorer. I can see my token ID here, which is 5AE72, which matches to 5AE72 here. So we know our tokens are wired up correctly because the ID matches. Now I'm gonna grab the manager, which now that I think about it, will probably be the same address as on, yeah, it's the same address as the manager on Binance anyway. So I could have linked it before or granted the role before. I grant the role. Now our manager can mint on Binance and it can mint on Avalanche. So now the final step is to actually mint some tokens, or not mint some tokens, interchain transfer some tokens. Note that my token does not have the interchain transfer functionality. If you want your custom token to have it, you can just inherit from wherever it is, this interchain token standard abstract contract. We went over this briefly before, but you can just inherit from it, and then your token will have the interchain transfer function built into it. I probably should have done it for this demo, but I didn't. So what does that mean if my token doesn't have the interchain transfer function? I can't send it by calling the token. What I can do though is go to ITS, which does have interchain transfer built into it, and just bridge my token by calling ITS itself instead of by calling my token. So I'm gonna go, let's go 0.1. Hopefully that's enough gas. It's gonna need my token ID, not my salt. So my token ID I can find in my logs right here. Paste it in. Destination chain, we're going to Binance. Destination address is going to just be me because I want to be the receiver of the mint. The amount, let's just send like 1 token. Metadata, don't worry about that for now. I'm going to pass in 0x. If you actually wanted to have some executable data, so like send your token and I don't know, pass in some like whatever helpful functionality, you can, this will be the place to do that. I'm not going to worry about that for now. Let's pass in my way here to actually kick this off while we wait. Call confirm. View my transaction. It was successful. And now let's check it out on Axelerscan. Give it a minute for Axelerscan to pick it up. Any questions so far about all of that? This is gonna call it here, assuming this works. Sweet, we can see our interchain transfer is now picked up. We can even see our asset labeled right into Axler Scan. SCT is just the symbol of my token. I think I have it, yeah, right here. Simple custom token, I called it. You can see it's going from Avalanche to Binance. And yeah, we can call it right here. Hopefully, momentarily, we should see if I plug this Binance address in here to Remix. Oh, I'm on Binance. Right, because I granted the role before. So I can see my total supply is 100. That's just because in the constructor, we minted all these tokens. But hopefully when this goes through, we should see this increment by 1. Okay, what's your question? In your experience, what are the best practices for security in terms of wallets that own the token manager contract? That's a great question. The wallet doesn't own the token manager contract. The token manager contract is technically, like control is a very, I don't like that term. It's like different roles have different functionality, right? Like your wallet doesn't own the custom contract. Sorry. You mean if your wallet is like the operator as well? It's hard. Like I wouldn't say that there's any different functionality for having a cross-chain asset integration than having just your general best practice of how you manage your keys. Like you might want to have a multi-sig which controls this. So like when you're incrementing a flow limit, like it doesn't just come back to one person who can completely set the rate limit on his own. Rather you have like a multi-sig that does it. Oh, it's already executed. Let me give this a refresh. Oh, nice, went through already. So we can see here that it was executed. We even had a refund on the gas that I paid. I can see the logs here. Note it's just a contract call executed because remember, on top, underneath all of this is just a simple GMP function like we did last week. We can see interchain transfer was received, where it's coming from Avalanche. The source address was how much was sent, just 1. The executable data is just 0. Remember we put in 0x before. If I go to here, this 1 has now incremented. So we successfully have bridged our token from Avalanche to Binance. So if we recap, we deployed this vanilla token on 2 separate chains that had no relation to each other. These 2 tokens are completely custom. We registered the token with ITS. We linked the 2 tokens and we were able to call, I guess I should add, for interchain transfer to actually move the token between 2 chains. If you want a simpler way of doing this for now, as a reminder, we have the portal to play around with this. It's just not as flexible as if you do it on 2 chains. Remember how like I passed in a custom token manager type, which you can't always do for doing it on the portal. And yeah, I think that's all I have for today. I hope that was clear. If you have any questions, let me know here in the chat or on Telegram after. And I hope that was helpful.
Yeah, well, thank you so much, Ben. I think that was probably definitely helpful. And yeah, so we're getting close to the end time. If anybody has an extra question or two, there might be time. Otherwise, you know where to find us. Although I think it is worth mentioning, I think Ben's going to be out of town next week. So that's something to keep in mind, everybody.
Yeah, I'll try my best to monitor Telegram. But yeah, I'll be traveling for a wedding next week. Pretty excited.
Exciting. Love it.
Yeah.
Well, other than that, everybody keep an eye in the chat for announcements on next workshops, all of that. We've got one coming up, which is kind of exciting with the team. I actually really like the guy from it. So
Yeah. It's going to be the end of me for now. It's going to be the awesome Squid team. It's going to be
yeah, I love the Squid guys. So yeah, I have that to look forward to. So just keep an eye out for that. And if you as always, if you want to return back to this recording, because you feel like you missed something, they'll be posted shortly in both the Telegram and the handbook, and on the Cracked Labs YouTube channel. There's a playlist for it with all the recordings. Other than that, thank you, Ben, and safe travels.
Thank you guys. Thanks for having me. Have a good one, guys.
All right, bye, everyone.